Okay, so this is very similar to a test question. I will say the test question tends to confuse people because it'll say, and it's on your study guide too, so like you could go check that out if you want to know what I'm talking about. But it'll say select all answers that are perfect squares of linear expressions. For some reason, that word linear really throws people off. Like this parentheses, for example, is a linear expression because it's kind of like mx plus b. So that's what they mean. Everything that's like in the factor form right here, considered a linear expression. So we just want to know which ones would be squares of linear expressions. So show me with your fingers, and there can be like multiple that are. So just show me with your fingers that you for sure know are perfect squares. And you have two hands, so you can show me up to two answers. Even though there could be more. So seeing a lot of threes and ones, so we'll start there. Three, I think I saw more of. Class, do you agree? Is this a perfect square? Okay, so why is this one considered a perfect square? Because it's a whole number? Nope, no, that's not why. Why is that expression considered a perfect square? What does squaring mean?
Multiply an integer by itself.
To multiply by itself, or like an exponent of 2, which multiplies the base by itself. So this, having the parentheses around it and then being squared, is achieving that. It's literally squared. So yes, it's a perfect square if I'm putting parentheses around it and squaring it. Then that for sure is a perfect square. That's probably the easiest to recognize out of the ones that are there. Now, number 4 looks really similar. Is that one a perfect square? No, because all it needs is some parentheses around the whole thing. The only thing that is being squared is the 3 right now. So no, there is nothing that I could multiply by itself to get this. So this one is definitely not. So if you thought 4 was, make sure you put that it's not. And then the other number that I saw a lot of, let's make sure we're paying attention up here, especially today out of all the days. If there's anything that's like very discovery based, it's today. Number 1 I saw. Now it's not like the exact same parentheses. Does it matter? Is it still saying that it's this times itself? All right, it is. Because does order matter in addition? Doesn't matter. 1 plus 2 is the same as 2 plus 1, right? So because of that, it's a perfect square. But really, you just have to watch out when there's subtraction in there. Miss Medina. Okay. So that one is a perfect square. It can be reordered, that parentheses, because and to make it look more like a perfect square, because the x would still be positive, the 5 would still be positive, like they're saying the same thing. The only thing to watch out for though is subtraction. So I think this popped up on one of your homework, something similar to this. These are not the same parentheses times itself. Max, close it. This is not the same parentheses times itself. Because even if I were to reorder it, you're not supposed to like change the signs that are in front of each term. This is a negative x and this is a positive x. So it's not the same thing. And then furthermore, this is a positive 5. This is a negative 5. So that would not be a perfect square. And you should know order matters in subtraction. So it would have to be like saying the same thing with the numbers having the same signs if they're out of order. All right, so questions on what I've said so far? Is there any others that would be a perfect square? Tell me with your fingers if you think there is. Any others from the list that would be a perfect square? Okay. So I see at least 4 people saying that 5 is a perfect square, and they would be right. It's not as easy to see from the standard form. It is possible though, like on Friday's lesson, we looked at how anything that is a perfect square trinomial has a perfect square for the first term, a perfect square for the last term, and that middle term is always 2 times the square roots. So like the square root of x squared is x, the square root of 16 is 4, and 8x is 2 times x times 4. So that's one way to recognize it. I think it's just easier to factor it because you need to know how to factor anyway. It gives you like less things to memorize if you just know how to factor. And if it's the same number that goes here and here, then that is going to be a perfect square. So what times itself will give us 16? And the reason why I said times itself is because we want it to be the same number if it's a perfect square. Does 4 and 4 also add to 8? So yes, in the factor form, it'd probably be easier to see that it's a perfect square. If it's x plus 4 times x plus 4. So yeah, we already said equation or expression 4 is not a perfect square. We can easily see that number 2 is not a perfect square because they're not exactly the same either. That's a difference of squares actually. And the last one, I would recommend you factor and see if it's a perfect square or not. So ideally, if we're looking for it to be a perfect square, you want these 2 sections to be the same. Is there a number that times itself will give us 20? Right, 20 is not a perfect square, so no. And even so, I was thinking of what could make it work. And I can't think of any. Here's all the factors of 20. Like, I think this one's actually prime, but it's definitely not a perfect square. Questions on the warm-up? All right, so identifying whether or not something's a perfect square or not is really key to this lesson. That's why it's the warm-up. Because in this lesson, you'll see what it means to complete the square. So there's lots of methods for solving quadratics, and you'll see that in certain situations, it's easier to factor. In others, it's easier just to like isolate the x. That's all we've learned so far. You'll add this to your list of methods, and then after that, there's just one more that you have to learn. So we're getting close to the end of this unit. So completing the square will make something a perfect square trinomial so that you can solve it easier, like how we did on Friday. That's what we're going to do today. I'm recording right now. The video from last year might be a little more helpful than the video from today because it'll be longer because today's a Monday. But, you know, we'll revisit this again on Wednesday, so I'm not that worried about it. Just kind of need to see what we mean by completing the square today and how to do it. So the practice is lesson 12. It's in Schoology. You have a bunch of ways to prepare yourself for the next unit test. Make sure we're doing that in advance and not like scrambling at the end because the deadlines are like a lot closer than they appear. We are on lesson 12 today. So we're really like by the end of next week, we'll be done learning everything we need to know. Any questions? Okay. So we are going to complete the table so that each row has equivalent expressions that are perfect squares. So going from standard to factor form, you would have to factor. So you guys should know how to do 1 and 2. So I'll have you practice that. And then going from factor to standard form, we did that in unit 6. So you should be able to multiply that out. So I'll give you 3 minutes to do these 3 because they are review. 4 through 7 we'll probably have to do together, but you could try it if you finish these early. We'll go over these in 3 minutes. Okay, table 8, what would be the correct factored form for the first one? All right, well, we have no time to waste, so we'll come back to you, but you guys have that one. Table 9, what about for the next one? What's the correct factored form? Okay, good. I'm gonna write it in the condensed format and you'll see why that's helpful in the problems that we're gonna be doing with this. But yes, x minus 5 times x minus 5, since it's the same parentheses, we're gonna write it as 1 squared. And that comes from doing the diamond method. But really, anytime you're factoring, look for and factor out a GCF if there is one. There's not. So then you are setting up your diamond, A times C on the top, B on the bottom. So looking for two numbers that both sides is 25 and at the same time add to -2. And because they specifically said we're looking for perfect squares, we want these two numbers to be the same. So -5 times -5 makes it work. It adds to the negative. And it does multiply to a positive, so that is correct. Table 8, do we have a first one? X plus 3 squared. X plus 3 in parentheses squared, good. So that setup, it would be 9 on the top, 6 on the bottom. 3 and 3 multiply to 9, but add to 6, so that works. Now going from factor to standard form, we did that in unit 6. So table 1, what would be the standard form for this one? Good, and for that, you would not be able to just distribute the exponent. That's a really common mistake. Know that if it's a perfect square, you should get a trinomial. You've done so many now that like you've seen, it's always a trinomial. So when I do multiply it out, this is what I get initially. I combine my terms, so they are correct in saying that it's this for the C. But on that, okay, well, then this is where it gets a little more challenging, and that's why I said we should do D1 together. This is basically what we mean when we say complete the square. We want to fill in what number needs to go here so that it makes a perfect square when I factor it. So we're filling in the blanks. You can still use your diamond method to help you with this. So like number 4, we'll do over here. I don't have enough information for the C. That's actually what I'm trying to figure out. So I just won't have anything here right now. My A times C. Don't have enough information yet. But I do know what my B value is. Class, what's the B value? -20. Let's make sure we're looking at the screen. This only works. This is only helpful if you pay attention to what I'm trying to tell you. Otherwise, I should just show you the steps and move on. But this like actually really helps you understand it and how to do it if you forget the steps. So this is my B value. That's the only thing I can fill in. But we know that we're trying to make it a perfect square. So we want the same number here and here. So think about it. What plus itself will give me -20? That way, right? So my question, because I feel like some people didn't even think about it, they're just waiting for everyone else to do it. My question was, what plus itself will give us the bottom number? I'm kind of fluid, you don't look at that right. And that's -10 and -10, because since we want perfect squares, we want it to be the same number here and here. Now I have enough information to fill in the top, because we know that it was always these two numbers multiplied to the top and add to the bottom. So class, -10 times -10 is 100. That's what my C value is, because my A value is 1. That's what goes here. And then to fill in my factor form, it's x minus 10 in parentheses squared. Does that make sense? Okay, well then fill in these two. Try 7 as well. I know 7 can be harder. But what we just did is filled in those blanks using the diamond method still. So do that with these, and we'll go over them. Okay, so for number 5, table 2, do you have the blanks for number 5? Okay, so let's see, let's work through that. So that if you get stuck, this is what you have to do. I have the B value. I don't have the C value. So this is all I can set up for my diamond. And knowing that we multiply to the top and add to the bottom, and that we want it to be a perfect square right now, what plus itself class will add to 16? 8. Not 4, because that's like the other side of the diamond if that were the case. We want what adds to itself to give us 16. And then now that we have that, we can fill up the top of the diamond. 8 times 8 is 64, and that's what fills in the C value. The factor form is x plus 8 in parentheses squared. All right, Chris, what about the blanks in number 6? Right, then we probably shouldn't be sleeping during it, right? This is a really hard concept for students to understand. And this lesson does a really great job of teaching you why it works so that you can actually memorize it on your state tests and things like that. Versus me just telling you what the steps and you barely knowing how to execute them. This will help you execute them. So, set up your diamond. You only have so much information. Table 3, what needs to go on the bottom of the diamond? Because that's the V value. We don't have the C right now. So we need 2 numbers that if I were to add it to itself gives us 7. Chris, what 2 numbers? So that it's like the same number there and there, give me 7. So instead of like guessing and checking, what could you have done in all the other ones that we've already done to figure out what plus itself gives us that bottom number? Like, we're not just pulling random numbers out of thin air, we're being methodical about it. If you don't know what plus itself gives us the bottom number, what should you do, Kristen?
Divide this by 2.
Divided by 2, right? 16 divided by 2 is 8. Negative 20 divided by 2 is negative 10. What's 7 divided by 2? 3.5. Which I know is unusual because normally when we do the diamond method, I say like we don't want the decimal ones. But that's the only way to make it a perfect square out of this one, this B value. And then the top would have to be these times each other, which I remember from earlier is 12.25. You could put that. I'm going to put the fraction because I think it'll be easier to understand later. The fractions would be whatever 7 divided by 2 was, so 7 halves. multiplied together makes it 49/4. I'm gonna put that because that I think will make more sense later. When we do this one that has a B for the B, not even a number. Questions on that? Okay, I'm gonna make some notes. I'm gonna erase them. So think about the math that we just did and all these others. And like I even got you to say it just a few seconds ago. If I were trying to set this up, normally we wouldn't put B there, like we put the number there, but that's what they give us for these. What did we do in every other one to get the B value? Or not the B value, but these two values? We divided B by 2. So I don't know what B is, I have a variable for that, but whatever B is, we know we're gonna divide it by 2. And then we multiply it together to give us the top value. So I'm just gonna write it as B over 2 squared. That's what it is. Over here, I'm gonna fill in the top number was B over 2 in parentheses squared. And this over here is just B over 2. Which is what ended up happening. This is negative 20 divided by 2. This is 16 divided by 2, and so on. This kind of helps you make a rule for yourself. That if you were needing to add a number to both sides to complete the square, that's going to be a test question. It says what number needs to be added to both sides to complete the square. You would just take half of whatever B is. And then if you needed, well, half of whatever B is, square it, and then you put it right there. All right. You have a spot to put some steps, so I'm going to scroll. We filled this out. These are all typed up. You can copy them. But some of these steps should sound familiar from what we just did, so just start writing them down. Steps for completing the square. First, in order to complete the square, we don't necessarily want it set equal to 0. We want it set to where the constant is alone on one side. So whatever C is, we move it to be alone on one side. Then we are taking half of B, which we just did. B divided by 2 is taking half of B. We're squaring it, and then we're adding it to both sides. That's how you complete the square. What that does is it creates something that can be written as 1 parentheses times itself. So like here's an example. Once you factor the perfect square trinomial, you write it in the condensed form. Because we saw that that was easier to solve on Friday. Because all you have to do is square root both sides and solve for both of your solutions, because there's usually 2. So this just really straightforward, tells you exactly what you need to do. You just need to know how to execute it. So for now, just make sure you have these steps written, like word for word, these steps. Because it's Monday, we don't have as much time today. But like this is already rewritten with the C term alone on one side. You take half of B, so what's half of negative 16? Then you square it, what's negative 8 squared? 64. 64 is what you would add to both sides to complete the square. That'll be a question on your test. What number needs to be added to both sides to complete the square? Well, in this one, it's 64. And you take half of B, square it, and add it to both sides. Then you factor it. This one becomes x minus 8 in parentheses squared. On the right side, it's just 4. And then it's just the same thing we did Friday where you isolate that. So undo what's being done. and make sure you get both of your solutions. But we'll revisit this on Wednesday, so don't be, it's got to do the steps today.